Assalamualaikum. Okay, so since I'm on my birthday off, okay, we'll try to look at example 11 on page 120 via YouTube. Okay, so again, feel free to slow down, speed up, okay, or skip any parts that you already understood. Okay, so for example 11, okay, let's read the question first. Okay, they say find the equation of the line which passes through the points A, which is 102, and then B, which is 2, 3, negative 1. Right? Okay, so as mentioned earlier, when we want to write it in vector form, okay, we need two information. We need one point on the line, okay, so that we can get the position vector of that point, and then we also need the direction vector of the line. Okay, so the point that they give, this A and B, okay, let's write it here. Okay, okay, your A is 102. Okay, they write it in coordinate form, but I'm going to write it in column vector form. Okay, and then B is equals to 2, 3, negative 1. Okay, because I write it in column vector form, I cannot just write B and A. I need to write it as OB and OA. Okay, that means I need to write it as position vectors. Okay, right. So next is I need to find the direction first. I can use A or B like this, right? OA or OB to be the point on the line, but I need the direction vector. So the direction vector, because we are finding the line that passes through this, right? So the direction, we can take it as AB. Okay, so to find AB, we are familiar, right? It should be OB minus OA. Okay, which means, if you calculate correctly, is 1, 3, negative 3. Okay, so we got the direction and we got one position vector over there. Okay, so therefore the equation is R is equals to 102 and then plus t times of 1, 3, negative 3. Okay, take note, if I don't want to use 102 and I want to use 2, 3, negative 1, it's still fine. Okay, the position vector is, as long as it's the point on the line, should be fine. Okay, there's no worries over that. Okay, so you see on your book, right, on the right side, they did mention that you can put it as 2, 3, negative 1 plus t times of 1, 3, negative 3. Okay, but the direction vector is what matters most. Okay, you cannot change that. Right? Okay, then what if your direction vector is, you actually take BA the other way around? Again, it's fine. Okay, because we can just flip the t to be a negative sign. We can still get the same points. It's fine. Okay, alright, so let's proceed. Okay, the next one we are going to do is determine whether or not the point 3, 6, negative 4 is on the line. Okay, we actually have an equation of the line already. Okay, so to confirm or verify that the point is on the line, we need to plug it in here. Okay, so for this one, they say determine. That means we are not so sure. It may or may not be on the line. Okay, okay, so what we do is we plug in the 3, 6, negative 4 as a 3, 6, negative 4, okay, as a column vector, okay, and then we see whether it tallies or not. So we're going to use this 102 plus t times of 1, 3, negative 3. Okay, so once you do that, you'll see that if you want to solve the first line, 3 is equals to 1 plus t. Okay, 3 is equals to 1 plus t. It will lead you to have to say that t must be 2 because 3 is equals to 1 plus 2. Okay, then what you do is you need to plug in these 2, right? Okay, and see whether it tallies for the y and the z. Okay, so in the book they actually plug in the 2 over here straight away. Okay, so we have they put in all the numbers there. Let me see. Okay, so what they did is they look at the right hand side first. So it's 102 plus 2 times of your 1, 3, negative 3. Your answer to this is actually 3, 6, negative 4. Okay, you can check. 1 plus, okay, the first one of course because we derived the 2 from there, right? Okay, we arrived at 2 from there. So 1 plus 2 is 3. 0 plus 6 is 6. And then 2 plus negative 6 is negative 4. Okay, so therefore, because of this, 3, 6, negative 4 lies on the line because it tallies with this vector equation of the line. Okay, So moving on. Part C, find the angle between the line through A and B, that particular line, and the line, another line which is 3, 6, -4 plus t times of -1, -2, and 1. Okay, so when you have two lines, right? Okay, when you have two lines that meets, okay, and you want to find the angle between them, okay, all you have to do, okay, is you need to identify what's the direction vector of the line. Okay, but in vector equation form, the direction is always this. Okay, the second term, the one that has the perimeter with it alongside it. Okay, so the two lines concerned, right? The direction vector for this one is 1, 3, -3, while the other line is -1, -2, and 1. Okay, so let me write it down. Okay, so the direction vector that you should be looking at will be 1, 3, -3, and then the other one will be 1, -2, and 1. -2 and 1. Okay, so this part is actually going back to your earlier topic, whereby the angle between two lines, okay, you can actually use the dot product. Okay, so basically what they did is they dot these two directions first. Okay, so that direction will be, when you dot it, it will be -10, right? So to find the cosine of the angle is A dot B divided by modulus A modulus B. So I'm not going to write that down because this one is from a previous topic, right? Okay, then once you plug that in as the cosine theta, you will have two answers. Let me see. You have 159, okay, or 21 degrees. Okay, so why are there two answers? Because when you have two lines that meet, right, there will be one acute angle here. This is the 21. Okay, so this is your 21, and then the other side will be your 159. Okay, so one will be acute, the other one will be obtuse, right? Okay, so that is all for example 11. Let's just finalize. See, at page 121, they mentioned the angle between the intersecting lines is the angle between the direction vectors. Okay, so let me see. Okay, so as of now, they didn't mention what is the direction vector as yet. Okay, but if they did mention, you need to be careful if it's going this way. Okay, then the answer needs to be 21, because only 21 is the two vectors are protruding out. Okay, so this one is actually covered in the previous topic of dot product, right? Okay, so I won't be delving much into it. Okay, so that's it for example 11. Okay, so I'll proceed with the next video. As of now, you can take a look at exercise 3M for some of the questions for you to try. Okay, right, so Assalamualaikum.